insecure, don't know what for. You're turning heads when you walk through the door. Don't need makeup to cover up. Being the way that you are is enough. Everyone else in the room can see it. Everyone else but you. Baby, you light up my world like nobody else. The way that you put your hands.
Assalamualaikum and hi. We are from Group 5 and we're gonna do a video presentation for subject MAT 183. In this presentation, we will explore the topic of maximum and minimum problems. Through the presentation, we will solve a specific example of a maximum and minimum problem, explaining the steps and methods involved. Let's begin by understanding the problem statement and how to approach it. First one is, what is differentiation? Differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. Second, what is maximum and minimum problem? The maximum and minimum problem involve finding the largest or smallest value of a function using its derivative to identify critical points and classify them as maxima or minima, considering endpoints for closed intervals. Why it's important? It's important because it has ability to optimize solutions, analyze function behavior, identify critical points, and apply to real-world application, like academics and engineering. This problem enhance problem-solving skills, develop analytical thinking, and provide the tools to predict and control outcomes in dynamic system.
Practical application. The practical application of maximum and minimum problems have many practical application in everyday life, especially in optimizing resource, improving efficiency, and achieving specific goals. So, this is example for practical application in life. First, determine the production volume and selling price to achieve the high profit. Next, find the short or fast route to minimize travel time and fuel consumption. And lastly, design training program to maximum athlete performance and reduce fatigue.
Hello everyone, today we'll go through a problem about maximizing the area of a rectangular field given specific constraint. Let us dive in. So this is our question. We are tasked to constructing a rectangular field using 4,000 meters of fencing, and the field have of the length x meters and the width of y meters. So our total of fencing is 4,000 meters. So it asks us two questions here. A. Show that the total area of the field is A equals to 2,000 y plus y by the power of 2. And B. Find the dimensions of the field that will maximize its area. Now let us dive in. I already made the solution, so let me explain it briefly.
6.5 hours later.
So, for question A, the total length of fencing represents the equation. This equation 2x plus 2y equals 4,000. And then now, we cut down the 2 and 4 and simplify it to make it simpler to x plus y equals to 2,000. Or equivally, we're going to make the x as an expression, and now we got 2,000. We got x equals to 2,000 minus y. But for area, the formula of area of rectangle is A equals to x and y, xy, substituting x with this answers, and then we expand this then we expand this, and then it gave us 2000y minus y by the power of 2. Now let us go to the next question. The next question is, find the dimensions of the field that will maximize its area. So this is our questions here. This is our answer. Now it asks us to find it, right? So step 1, we need to differentiate a with dA to dA over dy. dA over dy is 0, but while making this, our dA over dy is 2000 minus 2y. And then we put the 0 at the place of dA over dy. Then we will get 0 equals to 2000y, 2000 minus 2y. And then step 3 is our second derivative test. The second derivative test is basically we're going to differentiate our numbers again. So by differentiating it, 2000 will reduce to 0 and negative 2y will reduce to 2. So since d to a over dy2, which is, it confirms that it's a negative, and which is negative, this confirms that y is equal to 1000, and this has given us the maximum area given. And now step 4 is to find x. Well, this one is easy. With this y, we're going to substitute it with our answer with our equation before, and then we'll also got 1000. So our final answer is the dimensions of the field. So our final answer is the dimension of the field that maximizes area is x equals to 1000 meters, y also 1000 meters. So the field is a square which side length of 1000 meters. This completes our solution. Thank you, and let me know if you have any questions.
In conclusion, differentiation is one of the basic ideas of calculus, which means that it gives the measure of a function that depends on an independent variable. In solving maximum and minimum problems, critical points are determined using derivatives, as they help in determining where the function contains the largest or smallest values. It is important to note that the differentiation has come to play an important role in optimizing solutions, analyzing behavior, and providing solutions to real-world problems in economics and engineering. By developing problem-solving and analytical skills, it equips us with the tools to predict, control, and optimize results in dynamic systems.
So, here is our references for this presentation video.
That's all from us. Thank you and have a nice day.